Hi everyone, welcome to the video lecture series of Object-Oriented Programming. In this video lecture, we'll be discussing about how to represent a use case diagram. In the previous video lecture, we discussed about use case diagrams. We found out that use case diagram is one among the 9 UML diagrams. We also discussed when to use case diagram and what all will be represented or what a use case diagram will explain to us. All those things we have discussed. In this video lecture, we will see how to draw a use case diagram, how to represent a use case. All those things will be covered in this video lecture. So let us see how to draw this. So how to represent a use case? We know that use case diagram can be defined as a set of use cases. So we must know how to represent a use case. That is what we are going to focus on in this video. So a use case model can be documented by drawing a use case diagram and writing an accompanying text elaborating the drawing. It's similar to saying that when we write a program, we often write comments explaining the meaning or the use of that line of code. We know that there are single line comment and multi-line comments when we do programming. So comments are used for documentation. Similarly, when we draw use case diagram, it will be better if we draw use cases and along with each use case, we'll be adding some text indicating the usage of or the purpose of that use case. Now how to represent a use case? To represent a use case, we use ellipse. That is the shape ellipse. So use cases are represented by using ellipses. So we'll be drawing some ellipse and inside that ellipse we'll be writing the name of the use case. Okay, and the entire system, or we can say that all the ellipses that we draw will be combined together, will be grouped together by drawing a rectangle. That rectangle forms the system boundary. It will be more clear to you when we see some examples. But just now, just visualize a picture in which there are so many ellipses. All the ellipses are drawn within a rectangle. So all the ellipses forms our use cases and the rectangle forms the boundary of our system. System means the product or the software which we are going to model. The diagram of which we are going to draw, that is known as a system here. Okay, and which system or what kind of system or what's the name of the system that we are going to represent by using this use case diagram. That name of the system will be written inside the rectangle. For example, if you are drawing or if you are representing library information system, then that name will be written inside the rectangle. So basically a use case diagram is a rectangular in shape. Inside the rectangle we'll be having so many ellipses. Each of the ellipses represents the use case. Okay, and inside the rectangle there will be the name of the system that we are going to display, that we are going to model. Now how to represent the persons or the users of the system? We know that use case is actually the interaction between the user and the system. So now we know how to represent the system, how to represent the system use cases. Now we need to know how to represent the users who are going to use the system. To represent the users of the system, we use stick person icons. All of you know how to draw a person like this icon, stick person icon. There will be so many lines, right? At the top there will be a circle, then one vertical line. Then for drawing the legs, we'll be drawing towards left side and right side, two lines will be drawn. And to indicate the hands, we'll be drawing a horizontal line just below the head. That is known as the stick person icon. And each user of the system or each stick person icon is known as actor in use case diagrams. So an actor means it is actually the role played by a user with respect to the system that we are going to display. So the same person may act in different ways. That I mean the same personality or the same user may use a system in different ways. So for each user, we'll be having a stick person icon. And the line connecting an actor and the use case is called a communication relationship. So now visualize our use case diagram. Just visualize in your mind. We have a rectangle. Inside the rectangle, we have so many ellipses. Each of the ellipses will be having a use case name. So each of the ellipse represents a use case. Rectangle represents the system that we are going to model. And we'll have this stick person icons that is coming outside the rectangular shape. It is these users who are going to interact with the system. So there must be some lines connecting the user, the stick person icons, and the use cases that is inside the rectangle. These stick person icons are known as actors. I hope you all got an overall idea how the use case diagram is going to appear. We will see an example, but before that, just visualize how it is going to be. When we say that when we say about actors, it may not be the human beings alone. It may be some other systems. For example, if you are drawing the use case diagram of an internal operation of a system, one part of the system may be using another part of the system. So the part of the system that uses or that invokes or that is communicating, that also act as a user. So it is not compulsory that every time it has to be the human beings who has to be the actor or the user. It may be some parts of systems can also act as the actor. So if some part of the system is acting or some part of the system is using a part of another system, in order to represent that that is not a human being, we'll be using this stereotype. That stereotype means to indicate, to provide some additional information. That is what we mean by stereotype. So if it is a system that is acting as an actor, then we have to represent that by these double angle brackets, and then we have to write the external system, indicating that it is not a human being, it is actually an external system who is going to communicate with the use case. Now, what is the usage of this stereotype? Stereotypes are used to reduce the number of different types of symbols that we have to remember. For example, we know that UML diagrams are used to make it easier to understand the system. We are actually representing a system in different diagrams. That is known as UML modeling. So when we model something, it must be in such a way that it is easier to understand the entire system. So if we are going to give different shapes for each and every minute thing, then there will be a list of shapes that we have to remember when we have to draw some diagrams. That becomes really complex and really difficult for us to draw as well as for the people to understand. So we'll just minimize the number of symbols required to draw to represent something. That is why we are using this stereotype. Okay, the stereotype means one shape represents a set of things. For example, stick person symbol that represents all those things that interact with the system. It may be human beings, it may be a robot, it may be another part of the system, it may be something else. Whatever may be the thing, those or whatever things that interacts with the system are considered as actors, and all actors will be represented by using stick person symbol. So that reduces the complexity. Otherwise, think like this: if the actor who is going to implement or the actor who is going to communicate with the system is a human person, is a human being, we are using one symbol. If the actor who is going to communicate the system, if it is another system, then for that we will be using another symbol. So if we are providing a symbol for each and everything, there will be so many symbols that we have to remember when we draw a system, when we draw the diagram. Also, the users also will have to study the meaning of each and every symbol. So as the number of symbols increases, the complexity increases. So in order to avoid that, UML provides this stereotyping. So stereotyping means a list which shows that what all things will be represented by each symbol. Okay, that is known as stereotyping. So this is an example for this tic-tac-toe game, the use case diagram of a tic-tac-toe game. As we can see, there is only one actor, which is the human being who is going to play the game. I hope all of you know what is tic-tac-toe game. Anyway, I'm not going to explain about the game. It's actually a game. For those who don't know what is this, just understand this much. It's a game actually. So we have a use case. This is a system boundary. This rectangular shape that's known as a system boundary. And see the system name that is written here. We have written the system name here, and see the ellipse drawn here. This is the ellipse. This is the use case. So in this use case diagram, there is only one use case. It's not compulsory that in every use case diagram there has to be only one use case. It depends upon the system we are going to model. So in this example, there is only one use case, and name of the use case is play move. So use case represents the interaction or the action that the user needs to perform. So since it's a game, the user needs to perform only one action, that is to play the move. And this is the communication relationship between the actor and the use case. So the rectangle shape, that is a system boundary, system name, the use case name, the actor, and the communication relationship. I hope you understood this diagram, and this is how our use case diagram looks like. Okay, so our use case diagrams may consist of so many ellipses like this inside the rectangle, depending upon the system we are going to model. Okay, now there are certain relations that you have to indicate when we draw use case diagram. That is what we are going to see next. One relation is generalization. So when we have to use generalization, okay, so generalization is used when we have one use case that is similar to another, but does the something slightly differently or something more. For example, here pay membership fee. There is one use case. Pay through credit card and pay through library pay card. Both of these use cases are doing the same thing. This use case is also paying the membership fee. This use case also paying the membership fee. But they are doing slightly differently than this one. So in order to show such relationship, we have to use generalization. Okay, so here you have to show the arrow mark towards the base use case. So this use case diagram we can read in this way. This pay through credit card user case and pay through library pay card use case are the generalization of, or they are the child or children of this general use case pay membership fee. So this use case pay membership fees is the base use case, and these two are the children of this base use case. Okay, so this first sentence you have to remember. When we have a use case that do the same thing as another, but they do it something differently or slightly differently or something more than the base use case, in that case we have to use this generalization relationship. Okay, and one thing we have to remember, that is the base use case and the derived use cases. These two are known as derived use cases. They must have unique name. The name must be different. They should not be the same. The name of this use case is pay membership fee. That name should not be used anywhere here. The names of these use cases must be different. That is known as generalization. Next we have includes relation. This relation implies one use case includes the behavior of another, in its sequence of events and actions. For example, suppose issue book is one use case. Okay, this is one action. If this action has to be performed, it also include check for reservation use case also. So these two use cases go hand by hand. That is, they has to be done together. That is what we mean by this include relationship. That means if this action has to be performed, this action also needs to be performed. That is what we indicate by this include relationship. And see how we are showing it. We are drawing a dotted line with an arrow mark towards the use case to which the base use case has to be linked, and that communication line must be labeled as include in a pair of double angle brackets. This is how we represent the include relationship. This is the syntax of the include relationship: the base use case, the common use case, and there has to be a dotted arrow line and the include label. Next is extends relationship. Okay, extends relationship is used to show optional system behavior. So this is how we represent the extends relationship between the use cases. We have the base use case, again a dotted arrow similar to the include relationship, but the label is extends. Okay, so it is used to indicate or show the optional system behavior. Okay, and this optional system behavior is executed only if certain conditions are held. Otherwise the optional behavior is not executed. So this extends is similar to generalization, but only thing is here we have to think of some conditions. That is, this optional system behavior will be executed only if some conditions are met. Generalization is not like that. Okay, so the difference between extends and generalization is this: in case of extends, there has to be some conditions. Those conditions, if they are met, then only the optional behavior will be executed. If those conditions are not met, means the system behavior, the common optional behavior will not be executed. Okay, so these three are the most commonly used relationships that is shown in a use case diagram. Now we will see an example of a use case diagram. This is the example of ATM, a bank ATM. So these are the different actions that can be performed inside a bank ATM, isn't it? We can check balance, we can deposit fund, we can withdraw cash, we can transfer the fund. Okay, so these are the actions when we think about ATM from the viewpoint of a customer. When an ATM technician views an ATM, okay, he can perform the maintenance and he also can repair the ATM. So ATM, when we think about an ATM technician, these two are the actions this user can perform with ATM. When we think about a customer, a regular customer, these are the actions he can perform. So see the system boundary. This rectangle shape represents a system boundary, and here is the name of the system, that is bank ATM. See the use cases. We have altogether 1, 2, 3, 4, and 5, and 6, 6 use cases. Among these 6 use cases, 4 of them are related to a customer, and 2 of them are based on an ATM technician, and the bank have the ultimate power to all these use cases. And see the communication lines between the actors and the use cases. Okay, so in this use case diagram there are 3 actors: the customer, the ATM technician, and the bank. This is known as a stick person symbol. I hope you understood what's the meaning of that stick person symbol. Stick person symbols are used to represent actors. Okay, And here for bank, we don't have a strict person symbol because bank is a centralized authority. It's not a single person. So it's like an establishment. So that's why we are using some other symbol. Okay. So we will conclude our video lecture. So in this video lecture, we discussed about how to represent use cases, how to draw a use case diagram, how to draw the relationship between a use case actor and the use cases, how to represent system boundary. We also saw a sample use case diagram of a bank ATM. Okay. Now this is the assignment question for this video lecture. That is, draw a use case diagram of a library management system. Okay, draw the use case diagram of library management system. Draw it in a paper and it to me. Okay. Thank you so much.